So today we're going to cover statistics and measures. So a lot of you have probably covered statistical measures before. You probably think of them as mean, median, mode and range. And you're sitting there thinking, I know all about them, I don't have to do them. Trust me, by the time you finish today, you'll go away with a headache and think, I never knew they could be so complicated. Because a lot of people just think about the simple definitions and not the different ways that they can ask the questions, okay? So we're going to spend a bit of time today just doing the basics, but asking you the basics in a different kind of way, just to make sure you understand them. So the learning outcomes for today and tomorrow, there's only 3 of them, are calculate mean, median, mode and range. We're going to spend all of today and half of tomorrow doing that. Okay? So the problem is, today we're going to cover the basics. Tomorrow we need to talk about mean, median, mode and range, but with respect to data displays that we've used and frequency tables. And they start to get a bit harder tomorrow. Okay? Tomorrow we'll also do our learning outcomes 2 and 3. And these 2 are to do with the final stage of the data cycle. Because we've done stages 1, 2 and 3. Mean, median, mode and range are in 3. These 2 are in 4. So stage 4. So looking and interpreting patterns and exceptions, distributions and inferences are the final part of our data cycle. So we'll spend about 10 minutes each on these on the last half of tomorrow's lesson. Okay. So this is what Unit 1 is all about. This is why we're here. And this is the last lesson on Unit 1. So it's all about the data cycle. What kickstarts my data cycle? Why do I have data and deal with all these things? Good. There's a problem, there's a question, there's a hypothesis, and I need an answer. So what's the next thing I do? I need to know the average wage of teachers at the college. Good. You go out and you collect the information. Okay, and we talked about these stages in week 13 when we talked about questionnaires and planning how to do this. What's the next one? Processing. And we spent quite a lot of time doing processing, because processing is all of your data displays, your bar charts, your line graphs, and we did all that a couple of weeks ago. Processing is also what we did last week with probability. Theoretical probability was here, we flipped the coins, and then we came down here to that thing called relative frequency, didn't we? That's how we display probability. Today, we're still in stage 3, because mean, median, mode and range are all ways of processing the data. But instead of doing it as a picture, we do it as a number, the average wage, the average age, all that sort of stuff, okay? And then finally, good, interpret, discuss, conclude and so on, okay? And that's where tomorrow afternoon comes in. Those last 2 objectives about interpreting data is about completing our data cycle. So we've nearly gone full cycle. Don't forget, if you don't get the answer you want, you can go around this as many times as you like. Okay? It's not just a fixed once round. If you don't like the information, what did we do last week? We flipped the coin 100 times instead of 10 times and so on. Okay? Let's start the lesson then. Mean. Not nasty, but mathematically. What's mean? Good, yeah. So you add all the numbers together and divide by the number of numbers. That is what we call the calculated centre point of the data. Okay? So a mean, the calculated centre point of the data, and we calculate it just as the lad said, number of numbers, the sum of the numbers, so you add all your numbers together and divide by the number of numbers. Okay? So let's just do our own quick survey for a mean, shall we? Andre, how far do you travel to get to college, roughly in miles?
About 2. Yeah, 2.
2 miles. Okay. Morgan, how far do you travel to get to college? 12 miles, good. Ali? 50. Holy schmoly, Batman. Jordan? 5. Good. So we use that data. So to calculate the mean distance our 4 guys travel to get to college, we need to add them together. So 14, 64, 69. We divide it by 4 and it tells me 17.25. Okay? It's the total of our numbers, so we add them together and divide by the number of numbers. So it's 1, 2, 3, 4 people that I asked. You're thinking, oh, that's straightforward. And it is straightforward. It is really quite straightforward. So we talk about mean as one of the averages. When you watch the telly, when you're reading the newspapers and they say the average wage, the average this, the average that, what they really mean is the mean. Funny old thing. So when you see the average temperatures in Preston, they're talking about the mean temperatures in Preston. When they talk about the average fuel economy of a car, they're talking about the mean fuel economy of a car. And that goes for house prices, and it also goes for the average height of individuals over the centuries. Okay? Whenever you see the word average, they're generally, 99% of the time, talking about a mean. What I need you to understand by the end of today's lesson is that there are three averages. The mean is an average, the median is an average, and the mode is an average. And they're all used in different ways. And by the end of the lesson, we're going to show you the pros and the cons of each of those averages. Okay? And you need to know them because they test you on them. Okay? So mean is generally, in the bigger world, referred to as average. You need to realise that mean is one of three averages today. Okay? So, here's your little starter for 10 to do. I've got... So, what is the mean of these two sets? Shouldn't take you too long with a calculator. You just need to start bringing your calculators. Simple as that. Every week till May we'll be using a calculator. So the first one then. Generally the question will have 2 marks. Because you've got a calculator, you don't have to show all you're working out, but you do have to have an audit trail of where numbers come from. So, how do I get the mean of this? What's the first thing I do?
Add them all up.
Good. So you show the examiner, you're adding them up, and you get a total of 48. Okay? And then you're dividing it by 4 because we've got 4 sets of data, which gives me a mean of 12. Yeah. Okay.
Divided by 2.
Okay. The second set of data, I add them together, my total is 36. Divided by how many numbers?
6.
Okay. So you're sitting there thinking, oh, these medians are a doddle. Not a problem at all. I've got some really bad news for you. That is an F grade question. You get that question in the exam, generally it's going to appear as question 1 or question 2, and you just got to brace yourself, there's something harder in there. What I'm going to show you next is generally how the questions are put across. The way you calculate the mean of a set of numbers is the sum divided by how many numbers there are. Essentially it's a formula because I've got 3 variables, the mean, the sum of the numbers, and however many numbers I've got, and they can give you any combination of 2 of those values out of the 3, and they will test your understanding of means by giving you the mean and how many numbers you've got and seeing if you can work out the sum. Or they'll give you the sum and the mean. Can you work out how many numbers I'm dealing with? So the next few slides actually blow a lot of people away because they didn't realise the means could be so mean. Okay? So what you need to be able to do is rearrange this information so that if they give you the mean and how many numbers you've got, you can work out the sum. You also need to be able to rearrange this that if they give you the sum of the numbers and the mean, how many numbers am I dealing with? Okay? So you need to be able to manipulate this formula because that's what it is. It's got 3 variables that I can't do anything with until you tell me 2 of them. You could use a triangle, perfect. You know the old speed, distance, time triangle? You could actually create a triangle here of the sum of the numbers is the mean times however many numbers. So what we have is the speed, distance, time triangle, but applied to this because it's exactly the same thing. So the sum of the numbers is the mean times however many numbers I've got. If I know 2 of the things, I cover the thing I want up and it tells me what to do with it. And it's based on the speed, distance, time triangle. Okay? And basically this formula can be represented in a triangle where the thing that you don't know, you cover up. So if I don't know what my mean is my sum of my numbers divided by how many numbers I've got. If they give you the mean and how many numbers you've got, it tells you multiply your mean by how many numbers. Okay? So this is a far easier way for you to do those trickier questions. Rather than what you were trying to do yesterday, which is juggle algebra, which I do all the time, and John probably does all the time in his head, what we're going to do is I'm going to revisit the questions we did yesterday, and I'm going to show you how to do them with our new mean triangle. Okay, so our means, our nasty questions. Okay, so we did this one. Wayne scores 21 goals in a season. His mean number of goals per game is 1.4. How many games did he play? All you need to do, even on your worksheet, is draw that your mean triangle. Just remember S is at the top. It naturally follows that M and H will be at the bottom. So when you've drawn your triangle, write your information next to what you've been given. Wayne scores a total of 21 goals. So our total, our sum, is 21 goals. His mean number of goals, so it's telling you the mean, is 1.4. So to find out how many games he needed to score his 21 goals, you cover up the H, so how many, and what does it tell me to do with my S and my M values? Divide 21 divided by 1.4, and it tells me, as we found out yesterday, he needs to play 15 games to score those 21 goals. Can everyone see how our mean nasty triangle works? Yeah? This is going to help you with those nasty questions that we did yesterday. Okay? So let's just show you again another question that we did yesterday, but let's use our mean triangle. And you don't have to have one triangle, we can have two. They're the same thing. So here, because we're changing our mean, I'm going to use two triangles and show you how it works. So the mean of the mean of three numbers is 6. So the mean is 6, and how many numbers I've got is 3. So what's the sum of my numbers? How do I work out the sum of my numbers? 6 times 3, because that's what my triangle's telling me. So my sum for my three numbers of a mean of 6 is 18. Yeah, happy with that? Let's move on to the second part of this question that we did yesterday. An extra number is included and the mean increases to 7. So my mean is now 7, and because I've added another number, I've now got 4 numbers. So what's the sum of my 4 numbers now? 7 times 4, which is 28. So because I've gone from 3 numbers to 4 numbers, and my total's gone from 18 to 28, the number that I've added is, you see how that works? So here's one for you to do. Okay, so just recapping on what we did yesterday, so have a go at a very, very similar question to the one you've just done, but use Pete's mean triangle to see if we can't work out what the extra number has been added, okay? Hopefully, what have we done first? Drawn the triangle. What lives at the top of the triangle? S. So it tells us M and H live at the bottom. Colour code it for you. So how am I going to complete Pete's triangle for this one? What's my mean?
8.
Okay, mean is 8. How many numbers have I got?
5.
So my sum of my numbers is
40.
easy, isn't it? Yeah? Let's draw another triangle for the second set of data. I've got S at the top, my mean, and however many numbers I've got. So, an extra number is included. So how many numbers have I got? 6 numbers. What's the mean of the numbers? Reduces to 7. What's the total? 42. What number did I add? 42. 42 minus the 40 I had to start with. So I added the number 2 to my set of data. So my mean's gone down, which you'd expect. Yeah? Let's talk about medians then. So you thought means were easy. Well, wait till you do the medians. What's a median in statistics, in numbers?
The middle.
The middle.
Number, so you're going to put numbers in order.
Perfect. Yeah.
Find the middle.
So it's not just the middle number, it's the middle number of an organised set of data. Okay? Is that it? Is that just what a median is? Just the middle number of a middle set? Right. What's the most important thing when you think of a median? What alarm bells are going to go off in your head from now on when you see a median question? What's the first thing you think about when you're trying to find the middle? Yeah? But there's 2 middles. There's a middle for an odd set of numbers, and there's a different middle for an even set of numbers. So depending on the number of numbers you have, depends on how you find the middle. So if I've got an odd set of numbers, how many middles are there? Numbers in the middle? One. Okay? So when we deal with odd numbers, there's just a set value there. Okay? So when you get a median question, your first question is, am I dealing with odd numbers or am I dealing with an even set of numbers? If you're dealing with an odd set of numbers, jobs are good 'un because they fold nicely in half and there's one number in the centre. If you're dealing with an even set of numbers, so I've kept it nice and simple, I've got 4 numbers, where's the middle of those 4 numbers?
5 and 6.
5 and 6 are both in the middle,
So it'll be 5.5.
so you have to add them together and divide by 2. Find the mean. Let's use proper maths terms.
Yeah?
Okay. So we add them together and we get 11, divide by 2, and we end up with the mean of those 2 numbers, which is 5.5. Okay? So whenever you see a median question, the first thing that's going to go through your head from now on is, am I dealing with an even set of numbers or an odd set of numbers? Okay? So, let's talk about the odd set. I've got an odd set of numbers, okay? And we know there's one middle. So if I've got a random set of numbers like I have on the board, what's the first thing I do? Put them in order. So I've got to put them in order, and we put them in order, and what's the second question you've got to ask yourself?
What is the middle?
What is the middle? So I'm dealing with 1, 2, 3, 4, 5, 6, 7. What's the middle of 7?
3.5.
Good, and then what do you do with it? 3.5, and then
You round it up.
round it up. So your trick from now on to find the middle of a odd set of number is divide that number by 2 and round it up. So if I've got 7 numbers, divide it by 2, I get 3.5. Perfect. I then round it up, so it's the 4th number that is the middle in an odd set. And you're thinking, why do I need to know that? Because tomorrow I'm going to say to you, I've got 99 pieces of information. What's the middle of 99 pieces of information? Got calculators? Tell me the middle number in a set of 99 bits of information.
49.5.
So what would you do with 49.5?
48.
What did I tell you to do with it? Round it up. So the 50th number in that sequence of numbers is my middle number. So it might seem like a silly trick when you're dealing with 7, but tomorrow when we're dealing with 99, 100, whatever, we need tricks to give us the centre of this information, okay? Everyone happy with odd sets of data? Yeah, nothing hard there. Okay? Cool. Let's look at even sets of data. For an even set of data, how many middles do we have?
2.
2. There's 2 middle numbers, okay? So, we have our set of data. First thing we do is we put it in order. Here I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces of information. So the middle 2 numbers, divide 8 by 2, are the 4th and the 5th bits of information. So with my 8 bits of information across there, 1, 2, 3, my 4th bit of information and my 5th bit of information are the 2 in the middle. Okay? What I need to do then is what James said, you've got to add them together. So 29 plus 33 is 62. Divide by 2 to find the mean of those 2 numbers. Okay? The trick is to divide by 2, and that gives you the first of your 2 middle numbers. So, tomorrow, when I say I've got 100 bits of information, where is the middle of that information?
50. Oh. 49 and 50.
I've got an even set of data. How many middles are there?
2. So it'll be 51.
50th and the 51st. So you've got to add them together and then divide by 2. Whatever values are at 50 and 51, you add together and you divide by 2. Okay? So there's some basic medians for you, and then I'll get nasty with you. So work out the medians for those 2 sets of data for me, and I'll show you how they give you these nasty median questions. So let's look at the data for list A. What's the first thing I need to do with it? Put them in order. So I've got 1, 4, 6, 7, 7, 8, 9. Does that look right? Okay. So what's the first thing I think about when I see medians now? The middle number based on what? Good. How many numbers I'm dealing with? So I've got 1, 2, 3, 4, 5, 6, 7 numbers. The middle number of a set of 7 is the fourth number. So I just need to go along. 1, 2, 3. My fourth number is the value 7. Happy with that? Let's look at the second list of numbers. Let's put them in order. So this is a test in the exam. Do you understand the order of negative numbers? So what's the lowest number? So I got minus 10, minus 8, minus 4, minus 3, minus 2, and minus 1. So that's the first mark in the exam. Do you know how to order negative numbers? How many numbers am I dealing with? 6. So where's my middle for 6?
3.
And 4. Because it's an even set, there are 2 middle numbers. Okay, you get sick of me saying this by the end of tomorrow. So how do I work out what my median is? Add them together. So minus 4 plus minus 3 is minus 7. Divide by 2. Minus 3.5. Everybody get that? Yeah? Quite straightforward. You're sitting there, medians. Ha, easy. Wait for it. We're going to move on to mixed up medians. This is where they get nasty with you. These are the D level questions. So the ones you've just done are kind of the E, F grades. I'm not going to get you a C, okay? We're going to move on to the D grade questions that get you the marks that are set at level D. The median nasty questions all revolve around this fact that there's different ways of working out medians depending on whether you have an odd set of numbers or an even set. And they will always say there's a set of numbers and here's the median, and we add a counter and what's the new median. And the reason they do that is because when you switch and add one counter, you go from working out the odd value to working out an even value. And they play on that fact. Okay? Let me show you. I'll do an example and then I'll give you one to do yourselves. Okay? So the median of 5 numbers is 10. I don't know what the numbers are, I don't care. But the median is 10. I add another number and the median reduces to 8. What number did I add? So let me talk you through it. I've got 5 numbers. Don't know what they are, don't care. And it tells me that the median of those 5 numbers is 10. So how many numbers do I have in the middle of 5? 1. So the number 10 must live here. That is one of my data values because it's right in the middle. Yeah? Happy with that? So from that piece of information, I've created this and I know 10 lives there. Now, when I add another coin or whatever it is, another counter, okay, my median goes from 10 down to 8. So which side of 10 is my new piece of information going to go? Is it going to go to the right or to the left?
Left.
Why is it going left?
It's taking away.
Good. It's going to reduce what my median is. So something plus 10 is going to reduce my median to 8. So I know that this number plus this number is going to give me a median of 8. The reason I know what the missing number is because 8, according to my triangle, okay, sum, mean, however many numbers I've got, I know I've got 2 numbers and I know my mean is 8. So 8 times 2 equals 16. So the sum of my 2 numbers is 16. If I know one of the numbers is 10, what's the other number? You're happy with how I did that? You see how they're playing on the fact that you go from an odd set of data to an even set of data. This is their favourite median type of question. Okay? So the fact that you go from, you know, the numbers in order, spot the middle number, great. But that's kind of a lower level. This is where the marks are in the exam. So here's one for you to have a go at. I've been kind. Here are 5 numbers. I add another number and the median increases by 1. What number did I add? Okay. We're just about there. So how do I calculate mean? What's my first step? Put them in order. So I've got 2, 3, 8, 11 and 12. So before I add my counter, what is my current median? 8. Everyone happy with that? Yeah? When I add this new number, the median goes up. So which side of 8 is that new number going to live? The right, because the whole thing's going to increase. So it's got to live in here somewhere. So I do know that, using my triangle, okay, the sum is the mean times however many numbers I've got. I've got two numbers, and it goes from 8 to 9. So the new median is 9, okay? I've got two numbers, so the two numbers added together need to add up to 18.
Should be 10.
So I've already got 8, so the new number that I add is the number 10. Did most of you get that? You see where that's going? Oh, it's going to get easy now. So we've done tricky means, we've done tricky medians, mode and range. How difficult can they get? Saying nothing. Right. Mode, what's the mode?
The one that appears the most.
Brilliant. In the data, not the frequency. So it's the biggest frequency, but it's the one that appears the most. So in our simple list here, the mode is the number 4. Yeah? So you've got to look at all your data and find it. I don't know why I keep doing this, but I've sorted the data. I think I'm a compulsive obsessive. I keep sorting things all the time. If you get a list of data, you don't have to sort it to find the mode. If you visually can spot that 23 occurs 4 times and no other number occurs 4 times, your quid's in. Okay? So the mode is the number that occurs the most in your data. What's the problem with mode? I've got a couple of problems with mode.
What if there's two numbers?
Good. So what you could have is if there was another 20 in there, 20 would be the mode as well. And that's called bimodal. So if you end up with 2 modes, you could have bimodes. Okay, bimodal, 2 modes. There could be 3 modes. You could have, if I added a 4 in here, 3's a mode, 4's a mode, and 6 is a mode. We call that multimodal. So the problems with modes is there might be more than one mode. What's the other direction? What's the other problem with it?
Might not be a mode.
Brilliant. There might not be a mode. So if I've got data 1, 2, 3, 4, what's the mode? Well, there isn't one. Yeah? So mode is our third average. So median is an average, and mode is also an average. A mode is kind of susceptible to all these things. That's why they don't use them very much on the telly and stuff. There might not be a mode. The mode might be at one end of you. There's all sorts of problems with modes. But they're nice and simple. They're really simple things. Okay? So if I say, here's a list of numbers, scan them, what's the mode? Everyone see that 7 is the mode. Yeah?
7 and 5.
1, 2, 3, 4, 1, 2, 3. Okay? So you don't have to organise a list to find a mode. Don't have to do anything clever. Just need to be able to spot the number that occurs most often. Yeah? Okay. So wrapping up mean, median and mode. It's not a nasty question, but it goes back to what you've just done on medians. So 16 is the median of those numbers. One of the numbers we don't know what it is. We're calling it x. What I want you to do is find the median, and once you get the median, the value of x, what are the mean and the mode for that data? Okay, and this is what you need to be practicing. If you need more practice at this, if you go to the area 16 on my course, you'll find additional worksheets with the answers, and there's all these mixed up mean, median type questions to help you improve with the answers. You can mark them yourself. Okay. Right, let's do this then. So what's the first thing I need to do? Sort it. 3, 6, 6, 17, 24, 20, ooh, that was meant to be a comma, 28 and 37. Okay?
37.
So they're the points that we do know. And we know there's another value in there, x, that gives us a median of 16. Well, with 7 values, where's the middle value? 17. 7 divided by 2 is 3.5, round it up to 4. The fourth value is the median at the moment. I need to add a value of x that gives me a median of 16. Well, if 17 is the value at the moment, the new value must be less than 17. Okay? When I work out the sum of those two numbers, it's going to give me an average of 16. So 16 times 2 tells me it's 32, so the missing number is 15. Okay? Once I find out the missing value of 15, how do I calculate? So 15 is my missing value. How do I calculate the mean? Add them all up, what do you get? 136. Is that right?
Yeah.
Divide by 8. you get 17. So the mean is 17. And what's the mode? So can you see from one set of data how different a mean, a median and a mode could be? Yeah? Okay, last one. How hard can ranges get? Not very. So what's a range?
Gap from biggest to small.
So it's the biggest piece of data, take away your smallest piece of data. Again, compulsive obsessive, for some reason I've sorted it for you. Let's just delete that. So here's your data. Just go along your data, find your biggest value, which is 8, your smallest value, which is 2. 8 take away 2 gives me a range of 6. You're sitting there and you're thinking, it's not an average, a range isn't an average, but it's a statistic we use. I'm going to play a little game. What does range give me? When you get a question in the exam, the reason they ask you about range, and they'll give you some examples, is this word. They want to see this word.
Measurement.
What measurement? Like to play a bit of hangman? Give me a letter. A. I love it. 4 out of 5 classes have started with A. It always gets me going.
E.
E.
M. T.
That's you. You've maxed out. Anybody else?
E.
E. Got E.
E.
F. Sorry, I'm just selective hearing. When I hear the wrong answer, I go for it.
R.
R.
Amendment. D. Oh.
Sorry.
D.
D.
Tenderness.
M. This could be my first victory of the day.
This guy's getting on.
I. Come on, make my day. Make my day.
S. Hypothesis?
No guessing the word. Give me a letter.
Did you just say apples? Pizza.
O.
Caesar.
Consistent.
Y.
Consistency is the word. Range is a measure of consistency. Okay? You're thinking, what's he on about? Let me give you an example. Okay?
ENT.
Everyone happy with darts? The game of darts. Yeah? Quite straightforward. Three darts, you throw at the board, it gives you a score. Okay? I didn't have to explain it in the last lesson. Right? So player A comes up to the oki and he goes 1, 2, 3, 100. 1, 2, 3, 100. 100 and 100. So what's his range of his data? What's his highest score? 100. What's his lowest? So his range is. How consistent would you say he is?
Very consistent.
Very, very consistent. You could put him on the oki and he'll get you 100 every time. Let's look at player B. Goes up to the board. 180. 20. 180. 20. What's his range of data?
180 to 20. So it'd be 100.
What's his consistency like?
It's alright.
It's all right. So it's pretty rubbish. Yeah, it's all over the place. It's got a range of plus or minus 160 that he could end up getting. So range is about consistency. Now you're sitting there thinking, yeah, player A, consistency is great. Not always. Okay? Let's say we're in a game of darts. Got the last throw of the game. You need 180 to win. Who are you going to pick?
Player B.
Why?
Player A.
He always gives like 180 and 20.
Good. If we need 180 to win this match, if I pick player A, forget it. He's going to get us 100 every time. If I pick player B, at least we've got a chance of winning. You see what I'm saying? So consistency isn't always a good thing. Sometimes you don't want consistency. You want your maverick who can get you the odd 180, because that's what we need to win. So yes, consistency is a very small range. However, having said that, sometimes having a large range is a good thing. Okay? So that's just an example of why range equals consistency. That's what they're after, to see that word. Okay, good. So here's two sets of data, nice and easy, take you 30 seconds. What's the range of each set of data? You just have to find the highest and the lowest, take one from the other, and there's your range. So how about you? Okay, so the first set of data, what's my highest? Highest number?
10.
No, it's 11.
What's the lowest number?
3.
What's my range?
8.
Second set of data, highest number? Lowest number?
9.
Range? See how easy range is, okay? There you go. This is bog standard F grade mean, median, mode and range question. A rugby team scores the following number of points in 7 games. What are the mean, median, mode and range of that? So this is a noddy EF grade question. 4 parts, just checking your understanding of mean, median, mode and range. So let's start off then with the mean. What's my mean? What's the total of my data?
100. No, yeah, 105.
105. How many games did we play?
7.
7. So the
50.
mean is 15. What's the median?
15.
Yeah, 50.
So when I sort it all, I get 3, 9, 12, 15 and so on. So 15 is my median. What's the mode?
21.
Got 1, 2 21, so the mode is 21. What's the range of the data?
21 again.
Range is 21. Okay, nice straightforward calculations on a simple set of data. I'm not saying you won't get it, but if you do, then it'll be nice and easy. You need to remember the difference between mean, median, mode and range. Okay, whether you do it this way with a revision sheet or whatever. So the mean is the average of the numbers, the median is the middle number in a sequence, an ordered sequence. The mode occurs the most, and the range is the difference between the highest value and the lowest value. Okay? Some people at school remember it like this. Hey diddle diddle, the median is the middle. You add, then divide for the mean. The mode is the one that appears the most, and the range is the difference in between. I don't care how you remember it, but when you get a question in the exam on a mean, median, mode and range, you need to be doing the right things with that set of data. Whether you remember it from riddles or revision sheets, that's up to you. I'm going to finish the lesson off. Don't start packing away, we're not going anywhere just yet. By talking about the different averages and the pros and cons of those averages. Okay? And we've kind of hit on a few of these as we've been going through. So let's talk about the pros of a mean. So if I've got some data, 1, 4, 6, 8. What's the advantage of a mean? What does a mean do with these numbers?
Spots the average.
Sorry?
Spots an average.
It puts an average through, but a mean is an average. But what does it do with the data?
Adds it all up.
So it uses all of your data. So one of the advantages of a mean is that it uses all the data. Now, still got the data. In fact, I'll give you an example. We're working out the average wages of staff at Preston College, okay? And we say a cleaner on about 10 grand, 12 grand, a couple of teachers, 20 grand, 24 grand, a department head, 30,000, and then we get to the principal. Anybody like to hazard a guess?
42.
50.
125,000. Okay. So if I work out the means of these amounts, where is my mean going to sit? You reckon if you added them together and divided by 2, 4, 6,
Maybe it's around.
it's going to be well over here. It's going to be around 60k because of that big number. Okay? So what's the problem with a mean here? It's not accurate. What's it affected by? If we were doing scatter graphs, what would we call this? Good. So the problem with a mean is, because it includes all the data, if you have an outlier, something that really drags your data off to one end, you're stuffed because it's included, and what you find is the mean that you get is nowhere near where most of your information is. It's all askew because of one value. Yeah? See what I'm saying? So the advantage of a mean is it uses all the data, but in the same way, if one of your bits of data is an outlier, it drags off your information that way. Let's talk about the median then. What's the advantage of a median? What's the median of those numbers? 3. So the advantage of a median is I can spot it straight away. Let's add another couple of numbers. What's the median of that number? Those set of numbers?
3.5.
No, 2, 4, 5 of them. There's only one middle. So what isn't it affected by? So an advantage of a median is that it's not affected by outliers, because when you have an odd set of data, it sits in the middle of the data. Okay? However, if you have a set of data what's the median? 1. It's got rid of all our rest of our bits of information. So a disadvantage of a median is it's not always representative of your data. If it's 1 and I've got values of 2, 5 and 8, it's not even considered all my other values. So a median is easy to find and it's not distorted by outliers. However, it's not always a data value and it's not always a good representation of the data. Okay? Finally, mode. Got our numbers. What's the easy thing about a mode? Yeah, an advantage of it is you can see it straight away. What are the disadvantages we mentioned when we were talking about them? There might not be a mode, or
Might be more modes.
good, there might be 2, 3 or 4 of them. So a mode is easy to find and it's always going to be one of your data values. It's something that's in my list of information. Doesn't always exist, okay, or there might be more than one. Sometimes it's not a good representation of the data. So if I say to you, this is what's the mode for this information? 1.
What?
So it doesn't represent the rest of the data, because I've got 4 1s, a 2, a 5 and an 8. So a mode might be at one end of all your data. Yeah? So you need to know the pros and cons for each of the types of averages, because you get these follow-on questions that will ask you about which one is best, and that's exactly what you're going to do now. So here's a question for you, your last question of the day. Here are a load of holidays. We've asked people how much they spend, 7 families, how much they spend when they go on holiday. Calculate the mean, median, mode and range of these amounts, and then your follow-on question now is which is the best representation of that information. In other words, which average is the best average to use. What is the mean for that data? When you add all the values together and divide by 7, 1,000. Good. So the mean, when you add them together, is 7,000 divided by 7 is £1,000 per holiday. So the mean is 1,000. What's the mode? 100. We've got 1, 200s. What's the median? The middle point. 320 quid. And then finally, what's the range? 5,330. So the range is saying that our data is very inconsistent. It's all over the place. Which of my 3 averages, mean, median and mode, is the best one that represents that information?
Median.
And why would you pick median?
It's close to all the other numbers.
What else does it
It's
do?
not affected by the outliers.
Good. We've got an outlier, a very, very clear outlier. So what the median does is it gets rid of the outlier and it puts us roughly where we need to be in the middle of our data. Does that make sense? So you're now thinking about different types of averages. Okay? So when they say the average on the news, they should be saying mean, median, or let's talk about today. Today we need to consider mean, median, mode and range with display types and frequency tables. Okay. So let's go back a couple of weeks to stem and leaf. Anybody remember what stem and leaf shows me? What's it show me? Good, everyone get that? So the tens are on the stem and all my leaves are my units. So my key tells me 2, 6 is the value 26. I said when we did them, these were really good for 3 things to do with statistics. Anybody remember what those 3 things were? the median, the mode, and the range. And let me show you how. Okay? The median. What's the median? The middle. So if I tell you, well, there's 20 numbers there, what's the middle of 20 numbers? 10 and 11, because it's an even set, so there's two middles. So the good thing about an ordered stem and leaf is I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So 10 and 11 on my set of data there are 35 and 35. So the middle of those two, funnily enough, is 35. So I can find my middle, my median, really quickly. Mode. What does mode mean? The one that appears the most. Which one, just scanning that really quickly, appears the most?
35.
Ah, 35. Don't forget the stem. Yeah, 35. And then the range is the third thing I can find really quickly from a stem and leaf. So what's my biggest number? What's my littlest number?
5.
See how quick that was? So we can do a median, mode and range from a stem and leaf really quickly. If you get a stem and leaf diagram in questions 1 or 2, it won't ask you about these. If you see a stem and leaf at question 5, 6, 7, 8, 9, it's going to go on and ask you about these. So this is what makes stem and leaf useful. Okay? So generally when you get a stem and leaf diagram, it then goes on to these. Okay? Here's one for you. So that's a stem and leaf diagram. I want you to tell me the median, mode and range of that data. I'll be kind because it's on the board. 1, 2, 3, 4, 5, 6, 7. There's 21 numbers on there. So to say the median, let's do the median first. So I've got 21 bits of data. So it's an odd set of data. What's my middle? Everyone get 11. So 21 divided by 2, do it on your calculator if you have to in Unit 1, is 10.5, round it up. So it's the 11th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's my median?
34.
Good, 34. Don't forget the stem. What's the mode? Good, the number that occurs the most. And then what's the range? Good, because I've got 60 as my biggest number, 8 as my smallest, which gave me my 52. Excellent. See how simple it is? Median, mode and range on stem and leaf. Let's ramp it up a little bit. Let's take you back to some bar charts. Okay? They can ask you questions on bar charts to do with mean, median, mode and range. Because all a bar chart is another way of showing our data. Okay? So, as we look at the bar chart, we've got the number of trousers owned by 4 people. So if I ask you, what is the mean number of trousers people have or own? What's my total number of trousers? So how many have they got? So they've got 3 there, 8, 10, 3. So the total number of trousers these 4 people own is 11, 21, 24. So they own 24 trousers. What am I going to divide 24 by? 4, because there are 4 people. So the mean number of trousers that each person owns is 6. Can everyone see how I calculated a mean from a bar chart?
Add all.
Sorry?
Have you done add all of it and then divide by 4?
Yeah, you add all of your numbers of trousers. So this is our count of our trousers. And we divide by 4 because there's 4 people.
4 people.
Yeah? So that's the mean. The median, the middle of our data. So if this was data in a straight line and not on a bar chart, you would have, if it was ordered, 3, 3, 8 and 10. Can you see what I've done there? So if this was just a list of numbers, it would be 3, 3, 8 and 10. That's all the data that you've got on there. They're the frequencies. So what's the middle of that data? 3 and 8, because it's an even set, so that's 11. Divide it by 2. My median is 5.5. What's my mode?
Oh, 3. No, it's the one that appears the most.
Which one appears the most? Yeah? 10. No. 3. Yeah? This appears twice. Look at your data. 3, 3, 8 and 10. So the mode It's 3, because your data is 3, 3, 8 and 10. So the thing that appears the most is 3 pairs of trousers. Okay? And what's the range of my data?
10 minus 3.
Good. 10 is the most number of pairs, so it's the range of your data. Minus 3 is 7 pairs of trousers. So can you see from a simple bar chart, you can calculate a mean, median, mode and range based on the data. It's just another way of displaying this. Yeah, does that make sense? Good. Right, going to ramp it up a little notch. You remember this display from about 2 or 3 weeks ago, where we count the number of goals and the number of games that those goals were scored. It was quite a complex little table. All this is a representation of a frequency table. It tells me no goals were scored in 3 games, 1 goal was scored in 5 games, and so on. Okay? If you're going to work out the mean, median, mode and range with something like this, you need to know the total number of goals scored divided by the total number of games played. What you need to do is understand how this works. If I scored no goals in 3 games, what's the total number of goals I scored in those 3 games? None. If I score 1 goal in 5 games, how many goals did I score in total? 5. If I score 2 goals in 3 games, how many goals do I score? 6. So can you see what I'm doing here? 3 goals in 4 games, I'm multiplying them. 4 goals in 2 games, and then 5 goals in 1 game. Yeah? So to work out how many goals I've scored, I need to multiply the number of goals by the number of games. So this is what we call a frequency table, and we're going to come on to those in a minute, but we're still working on displays at the moment. So this display, this frequency display, shows the number of goals against the number of games. So to work out the mean, I scored how many goals? 11, 20, 11, 23, 31, 36 goals. So that adds up to 36 goals. Everybody happy with what I've done there? How many games did I play in? Well, I played 3 games here, I played 5 games there, 3 games there, 4 games there, 2 games there, 1 game. So 3, 6, 11, 15, 16, 17, I played in 18 games. So I scored 36 goals in 18 games, so the mean number of goals per game is 2. Can you see what I did there? Yeah? That's the mean. The median is the middle of all my data. Now this is where it starts getting slightly tricky. Okay? Now my data is literally 0, 0, 0, 1, 1, 1, 1, 1. So can you see what I'm doing here? This is actually an organised list of data. I have 3 lots of 0. So my count, my frequency, is my data. It tells me where the middle is. Okay? So the middle of my data is how many games did I play? Well, I played 18 games. Yeah? That's what this column represents. 3, 5, 3, 4, 2. That frequency is the number of games. So I played in 18 games. And I scored this. In those games I scored these goals. So it's telling me there are 3 zeros. There are 5 1s. There are 3 2s. Okay? 2, 2, 2. So this is shorthand for writing out all that data in longhand. So if I played 18 games, what are the middle number of games that I played? 9 and 10, because it's an even set. So to find my medium, it's the 9th game and the 10th game that I played in. So this is the first 3 games, 0, 0, 0. The next 5, 1, 1, 1, 1, 1, 1. So the 9th and the 10th live in here, because that's 3 and 5 is 8, 9 and 10 live in there. 3 and 5 is 8, 9 and 10 live in there. So what is the value of my 9th and 10th game? What's the median of them? 2. Yeah? So the median is 2. So the median is the middle of your frequency, because this is organising your data. It's saying 0, 0, 0, 1, 1, 1, 1, 1, 1 5 times, 2, 2, 2 3 times, 3, 3, 3 4 times, and so on. That's what a frequency table shows you. Okay? So to help you find the median, it's the middle of your frequency, and you'll see that when we do frequency tables in a minute. The mode, which one occurs the most? 1. Because it occurs 5 times. It's your highest frequency. So your mode is 1. What's the range of my data? What's the biggest number of goals I score? 5. What's the least number of goals I score? 0. So I have a range of 5. Okay? Because 0 is data. 0 is part of our data set. Okay? So using these complicated data displays is very similar to what we're going to do next, which is a frequency table. So let's get into the C grade stuff. So yesterday was D, E and F. We've just done a bit of C stroke D. This is C grade stuff, okay? Just before we go into the C grade stuff, to recap on what we've just done. So those diagrams that we've just done are all related to this. So remember last week we rolled the dice, and it rolled the dice and it went 6, and I'd record a 6, and we roll the dice again and it would go 5. Okay, that's our raw data. That's what we did last week. And what you do with your raw data is up to you. But basically, if you do a tally and I add my 6 and I add my 5, everyone remember what that is? 5 bar gate. Good. Okay. I get my frequency based on how many of each of these I get. So I have 3 1s, 3 2s, 3 3s, 3 4s, 5 5s, and 3 6s. Blimey. Okay. Now all a frequency is telling me how many of each number I've got. It's shorthand for what we just did. That means I've got 3 1s. That means I've got 3 2s. I need to add a 5 and add a 6. This is telling me I have 5 5s. This is telling me I have 3 6s. So a frequency table is already ordering your data. Just keep that in your head. So when we're trying to find the middle, when we do the medians of frequency tables, the data's already in order. We just go down and find the middle of the data. Okay? So keep this in your mind, that you have your raw data, the frequency table is just organising it for us, and it's shorthand for this. So that just means 3 1s, 3 2s. And what we're going to do next will be a lot clearer for you. Okay, so let's do this. I'll give you an example and I'll talk you through how we work out the mean, median, mode and range of frequency tables. Okay? Here we did a survey and we went round and we asked 20 people how many tellies they have in their house. Now in our day you'd have one and it was black and white and you could hear the valves humming all night. Okay? This day and age people have 2, 3. The kids have got tellies in the bedrooms. There's a telly in the kitchen for when it's really. So we did a little survey. How many tellies people own? So all this frequency table is telling me is that 3 people own 1 television, 4 people own 2. So it's shorthand for 1 1 1, 2 2 2 2 2, 3 3, 4 4 4 4 4 4 4. Yeah? It's just instead of having all that information, it's telling me 3 lots of 1, 4 lots of 2. So to work out my mean for my frequency table, I need to know how many tellies these 20 people have got. So 3 lots of 1 means there are 3 tellies. These 3 people own 3 tellies. These 4 people at 2 tellies each own 8 tellies. So you have to multiply your data by your frequency to get your total value. Yeah, the total number of tellies. Okay, so that's all this is doing. So this column here is adding up your value times your frequency to tell you how many tellies we've got. Yeah. So when I add this up, these 20 people own 70 tellies amongst them. Okay. So to work out my mean, it's the total number of tellies divided by the number of people. In math speak, it's the total value of my value times my frequency divided by my frequency. Okay? 70 divided by 20 tells me my mean number of tellies per house is 3.5. Okay? Let's look at the median. The median is the middle value of your data. In other words, the middle value of your frequency. So what's the middle of 20? The 10th value and the 11th value. Because it's even, it's the average of your 10th and your 11th. Sorry, the mean of your 10th and your 11th. So what you do is you go down your ordered data, because this is already ordered for you. So that's 111, 2222, so that's the first 3 values. That's the next 7, 8 and 9 are there. So 10 and 11 live in here. Does that make sense? So my 10th and 11th value are both the value of 4. So my median is 4. Can you see where I got my median? It's the middle of my 20. So my first 3, then another 7, 8, 9, 10 and 11 live in there. Let's look at the mode. All the mode is the thing that occurs the most. Well, the frequency tells me what occurs the most. And again, my frequency, my highest frequency, points to 4 televisions. Yeah? You there? Finally, my range. It's the range of my data. Not the range of my frequency, it's the range of my data. So the most number of tellies is 6. The least number of televisions is 1. So 6, take away 1, gives me a range of 5. So to work out the mean, median, mode and range of a frequency table is probably the hardest thing you'll have to do in Unit 1 if it comes up. Sometimes it does, sometimes it doesn't. So here's one for you to do. I've done you a favour. I've multiplied the frequency by the number of bedrooms. So this is our famous bedroom study. So we asked 50 houses, we knocked on the door of 50 houses, and we asked them, how many bedrooms do you have? 2, 3, 4 or 5. So I want you to find the mean number of bedrooms per house, the median, the mode and the range of the number of bedrooms. Ready for this first one then? So the mean. How do I calculate the mean? Good. So to work out the mean, you need to know what my total number of bedrooms are. So I've done that for you. It's 200. And you divide it by the number of houses you've asked, 50. So the mean number of bedrooms per house is 4. Everyone get that? Yeah? Nice and straightforward. So it's the total of all my data divided by that. So in order to get 8 people at 2 bedrooms, you multiply them together. And all that's saying is I've got 8 lots of 2. This is shorthand for yeah? That's all that is saying. I've got 8 lots of 2. So instead of adding 2, 2, 2, 2, 2, you just do 8 times 2 to get the 16. Does that make sense? So that's all this is showing. So that's all that data. The median then. So if I wrote it all out in longhand and you had 50 numbers, it would be really hard to find. Yeah? This is dead easy. So what's the middle of 50? 25 and 26. So I need to find the 25th and 26th number. They're already in order for you. It goes 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 2, 2, 2, 2, 2, 2. Yeah? So it's already in order. So where does number 25 and 26 live? In here. Yeah? The first 8 are there. So by the time I get to 25 and 26, they live in here. So the median is the number 3. What's the mode? 3, because it occurs 32 times. And then finally the range. Good, 5 minus 2, which gives me my 3. Excellent. Happy with frequency tables and mean, median, mode and range? Good, good, good. Right, the final bit, the hardest bit, sort of. Sometimes you will get frequency tables where the information, the data, is a range, it's grouped data. It can be continuous data, it can be a selection of values, in this case ages of 0 to 5, 5 to 10, and so on. Okay? Now, the information is identical to what you've just done, but when you're working out your totals, we haven't got a single value in here. We've got a range of data. So in order to calculate our mean and our median and our mode, we need to pick the middle of our range of data. So here, in order to work with something in mathematics, we pick the middle number. So if I've got an age range of 0 to 5, I pick my middle point, 2.5. So I then multiply my frequency, 6, by 2.5, and it gives me a total age of 15 years for those 6 students, okay, or people. If I've got an age range of 5 to 10, I pick the middle point, which is 7.5. So I multiply my frequency, 12, by 7.5, and it gives me a total age of 90 years. So in order to work our mean, we're now picking our midpoints and multiplying our frequency by a midpoint. And then when we add these up, we have a total age of 395 years for our 40 people. 395 divided by 40 is my mean. So my mean age of my 40 people is 9.875 years old. Happy? So it's just like you've just done, but because we've got a range of data here, we have to pick something, and we pick the middle value. Okay? Let's move on to the median, the middle number. Well, it's the middle of 40. It's the middle of our data. So the middle of 40 is and 21, because it's an even amount. So we go to our 20th and our 21st bit of data. So that's the first 6, that's another 12, so that's 18, 19, 20. The 20th and the 21st live in here. So your median can be the range 10 to 15, but what you take is the midpoint, because we have no idea where these 19 people live within this group. They could have been 19 10-year-olds. They could be 19 15-year-olds. So it's recommended when you give the answer to a median question on group data, pick the midpoint. So your median is 12.5 years old. Okay. Let's look at the mode. All the mode is the one that occurs the most. So 19 is the mode. So again, you've got a range of data, 10 to 15 years old. We don't know which value to take, so just pick the mid value and say your mode is 12.5 years old again. Okay? And then finally the range of your data. Now this time you've got some options, but you have to tell the examiner why you're picking that option. So your two main options are, you pick the midpoint of your data here, your biggest value, which is 17.5, and you can pick the midpoint of your lower value, which is 2.5. So you could end up with a range of 15 if you pick your middle values. Conversely, you could say, I'm assuming one of my 3 people is 20 and one of my 6 people is 0. So 20 minus 0 is also a valid range, but you have to say why you've chosen it. Okay? So either method for range is all right. You're happy with that? Last activity of the day then. Here's one for you. So we've measured the height of 5-year-old students, 100 5-year-old students. So the total of your frequency is 100. I want you to work out the mean, median, mode and range of these boys. When you work out the range, I want you to explain why you've got that number. And then the final question is, if I was going to plot this data on a diagram, which diagrams could I use? Okay? So I'll let you crack on with that. So it's a frequency table, but with grouped data. So everybody cottoned on to the fact that you have to take your midpoint, which is 85, 95 and so on, and multiply it by your frequency. And when you do all that, what's the total here for the years? 10,060. Okay, 10060. So in order to get the mean, what do I have to do? Good. So 10060 divided by 100 people that I asked gives me.
106.
It's not years, is it? It's heights. So the mean height of all this data is 100.6 centimetres. You happy with that? Everyone get that? Yeah? A lot of you did. That's good. Let's look at the median then. So, what's the median?
Half of it. The middle of it.
So 50 and
51.
51, because it's an even set. We've got two middles. So the 50th and 51st values. So, we've got 8 there, then another 31, so we're up to 39. So 50 and 51 must live in here. So my median is,
100.
what did we say we do?
105.
Good, 105. We take the midpoint. When we give a median on group data, give them the midpoint. So it's 105. Excellent. So the median is 105. And what's the mode?
I've got the 100.
Yeah, the most,
Yeah.
again, is 105. Take the midpoint. Finally, for the range, what did you get for the range?
115 minus.
You did 115 minus 85 gives me 30. Anybody get anything different? Did anybody go for 120 and 80? 120 minus 80 is 40. So you can have different ranges as long as you tell the examiner, I took the midpoints. So it says explain why. Say why you got that amount. Okay? For a bonus point, if I was going to plot this data on a diagram, what diagrams could I use? What sort of data did we say that was?
Continuous.
What are the two displays we use for continuous data? It's an exam question every time. Sort of a bar chart. Histogram. A fancy bar chart, which is a
She said it
histogram.
first, I'm not
Ah,
taking credit for that.
histogram, what's the other one?
Oh, you mean on the Instagram, because that's because
So the histogram is the fancy bar chart.
And
The fancy line chart, which is a
line graph.
frequency polygon. Remember these displays, they come up. Yeah? Which displays can you use for a continuous data, a histogram and a frequency polygon? You've got to get them in here. So can you see how mean, median, mode and range isn't as simple as add the numbers and divide by the number of numbers. It's the middle. You've got to consider all sorts of things, other display types and frequency tables and group data. Okay? So that's the end of learning outcome number 1. It's only taken 2 days, but we got there. You'll be glad to know that the next 2 we can do in about 10 minutes, okay? So what we're going to do next is we're going to talk about interpreting and discussing the data once you've done all this. So we're finishing off quite neatly the data cycle with just glancing at data and making comparisons and interpreting the data, okay? So data patterns and exceptions. So here's an example of what you could say with respect to this stage 4. Jerry has a hypothesis and he says that most days at his house are dry. He obviously doesn't live in Lancashire, okay? So that's his hypothesis. He then collects the data and he measures 20 dry days in June. And then he concludes that, and then we have to make a discussion on why this may not support his hypothesis. What's wrong with what he's done as part of his hypothesis? So we're in stage 4 now. So we collected 20 dry days in June. So 20 out of 30 days are dry. And he draws a little bar chart or a pie chart. And he says, oh look, 20 out of 30 is dry. Therefore, where I live is mostly dry. So dry, wet. He's drawn that. That's stage 3. So we're now at stage 4. And we're discussing what he's done. So discuss it. What is wrong with Jerry's hypothesis?
He's only measured it in June.
He's only measured it in June.
He's only measured it for 1 month.
And he's only done it for 1 month. So if he was going to go around the data cycle again, how could he improve his results?
Do it every day for the year.
Brilliant. Every day for the year. And then start boasting how dry where it is you live, okay? Especially what we're going to look at is distributions, okay? They'll give you tables of data and they will ask you what is the best way to compare the data. So in this example, we have years 7, 8, 9 and 10 and 11 at a school. And we work out how many male students and female students we've got. Now, part of our data cycle is deciding how to best compare this information. So, thinking about all the things we've covered over the last few weeks, how could I compare this data? A tally is one way.
Bar chart where the side by side.
Good, a perfect answer. A dual bar chart. So if I was going to compare the data where I've got males and females, the thing it's screaming out for is the dual bar chart. Good. What's another way we could compare it?
Composite bar chart.
Composite, you could put the males and the females together and you could compare year against year. Perfect. Another way, less visual. What have we been doing today? Not a frequency table, but that is a frequency table of sorts. But what can we work out from a frequency table that we've been doing today? Yeah, a mean, median and a mode. You could work out the various averages for this and compare them for each year. Okay? So when they ask you generic questions, which they can do, all they're asking you when they're saying compare the data is what is the best display or what's the best format for stage 3. Okay? Here we've got the data from 10 professional athletes running the marathon and their times in minutes, and the time for 10 amateurs that ran the marathon. So thinking about how we compare the data, what processes have we learned over the last 3 or 4 weeks that would be a good way to compare my professional athletes' results with my amateur athletes? Good. So straight away, work out the mean of my professionals and the mean of those. Not just the mean, the median, the mode, because they're all averages. You can do those, and even the range of the times, yeah? So that's good. So that's one way of comparing them. What's another way of comparing them? Bar chart. You could do a dual bar chart or even a composite bar chart and plot the data for these and compare your professionals against your amateurs. Okay, so there's lots and lots of different ways of comparing data. And that, as far as we're concerned, stage 3 and 4, comparing data, interpreting data, we've been doing it as we've been going through. Yeah? The only tricky bit was that last bit where you have to apply what you've learned to sets of data.